Okay, welcome back. This is Chapter 9, and Chapter 9 is all about operating systems. So, as always, let's kind of go through the learning objectives. So, turn to page 378. Define an operating system. That's pretty good. Describe the startup process and shutdown options on computers and mobile devices. Explain how an operating system provides user interface, manages program, manages memory, and coordinates tasks. Describe how an operating system enables users to configure devices, establish internet connections, and monitor performance. Identify file management and other tools included with an operating system. Explain how an operating system is used to enables users to control a network or administer security. Summarize the features of several desktop operating systems. Briefly describe various server operating systems, and summarize the features of mobile operating systems. Okay, so that's kind of a tall list. So here's a little graphic showing basically everything that your operating system is responsible for. We're going to go around this thing kind of clockwise. So starting with powering up your machine and shutting it back down. On page 380, they talk about the startup process, and it goes through certain steps, and let's just kind of go through that little list there. It talks about the power on. So, you hit the start button, and it produces power. Power goes through the circuit board, and so the next thing that happens after that is the CPU chip, the brains of the thing, says, ooh, I've just now got power. I'm going to reset myself and kind of look around and see what's going on. So it does that, and then it looks to do a self-test of the entire system. So it goes out and checks to see, what kind of devices I have attached, how much memory do I have, is the memory okay, all the little self-test things. And so it looks to see if everything's okay, and if it passed these power-on self-test, a post power-on self-test, then it'll say, okay, it's time for me to find the operating system. And there's a chunk of this called the bootloader. And the bootloader basically says, I'm going to look at all the devices that are typically used to boot the operating system up. And when I find those, I'm going to figure out which one to use, and then I'm going to just read information off that device, and hopefully that's an operating system that makes sense to me, and it'll launch. So that boot loading process. Now, everyone, the bootloader only finds one operating system, and so there's no choices going on. But I know people that are nuts, and they have a gazillion different operating systems on their system. So when they fire it up, it basically comes up, the bootloader comes up and says, what operating system would you like? And you say, well, I'd like, Windows 7, or I'd like Windows 8. They pick it off a list, and then it goes off and loads. And then the last step, of course, is the operating system actually goes through its little start. And so it kind of goes through another type of self-test and enumerating devices and creating a session and being able to have you log in and do your thing. Okay, so that's kind of how it boots up, is those few little steps. Now, on how it goes down is a little different. Most of the time, you tell a machine you want to shut down by clicking on something in the operating system. Normally you don't hit the button. Okay. You do hit the button to turn it on, but you typically don't, or at least you shouldn't, be hitting the button to turn it off. Typically what you do is you have some sort of a shutdown or a sleep operation. And depending on how the machine is configured and whether or not it's a portable device, it may actually shut the machine completely off, or it could just put it to sleep. And unfortunately, there's like 5 or 6 called sleep states. And depending on how your device is configured, just on how sleepy it gets, it could be designed to instantly return exactly where you were. So it's not a very deep sleep. So you hit the button, and then 1 second later, poof, everything, your email is exactly where you left it, and everything is fine. And there's other types of sleeps that are a little deeper, and so it takes a little bit longer to come up, and perhaps you might have to start your email message over a second time. And then it gets all the way down to, honest to God, real power off. Now, there's an interesting one called hibernate. And although what I'm getting ready to tell you is not absolutely positively true, because the term hibernate doesn't really associate with one of those sleep states. It's kind of a marketing term. But typically what happens with hibernate is the machine is actually, honest to God, physically turned off. I mean, really, 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 really off as off can be. And the only difference is when you hit the start button to start the machine over again, one of the things that it does, it says, hey, when this machine was shut down last, did it save a hibernate state? And what that basically means is it just took a snapshot of what was in memory and wrote it off onto a special file on your disk. And so as the machine is booting up, it just grabs that file, loads it into memory, and just picks up right where you left off. So it makes it look like it was asleep, but it really wasn't. I mean, really, really, you could hibernate a machine, take the battery out, leave it in storage for a year, come back, put a battery in and turn it back on, and it would just pick up right where you left off, because it's been sitting there for a year because it's really, really, really off. Okay, let's continue. They talk about some of the operating system functions, so we're kind of done with this one. Now let's talk about providing a user interface. Yes, the machine has to be able to talk to you. That's kind of sort of obvious. And this user interface is typically called a shell. The parts of the user interface that you can see, like in the Windows world, the little file explorer here, the little Windows Explorer guy, that's something that you can see, and that's an add-on to the shell. The shell is the part, of course, you can't see. It's the desktop. It's all the rest of this kind of stuff. This is all part of the shell. The fact that there's a desktop and a ribbon and all the rest of these things. Okay. So part of the user interface is a shell, a graphical user interface. And then, of course, you have the old style stuff. I mean, that stuff's still around. I mean, yeah, I can pop out to, a command prompt and still run old DOS commands. If you remember how DOS commands work, you can run those. And by the way, this is not really, really DOS, okay? It's not. It certainly looks like it is, but it's really, really not. It's just designed to look just like the old style DOS stuff. It's actually something completely new that's designed for 100% backwards compatibility. Okay, so a lot of people don't spend much time here because you have the graphical user interface, but occasionally you'll need to pop out, you're installing something, and it'll say, go out to the command prompt and type this goofy command, that kind of stuff. It happens. Okay, let's continue. On page 383, they talk about how the next thing we're going to be doing is talk about managing programs. So let's say I've got multiple things going on simultaneously. Well, how in the world is the machine going to figure out how to do this? Well, first you need to talk about what class of machine you're talking about. There are machines out there which are called single task machines, and typically they're very, very small things, like a very small phone or something. It can only do one thing at a time. I mean, you can't be surfing the net and writing an email at the same time. It's an either or combination. It's never, it's never both. And those are becoming very, very rare now. Most all machines now allow foreground and background tasks of some sort. I mean, the simplest thing is, let's say I've got a phone and I'm listening to a song. Okay, so I've got my earphones on and I'm listening to a song, and somebody says, quick, what's the square root of 144? So I want to use the little calculator function, and I pop over to calculator. Do you expect that the music would stop while I'm using the calculator? I wouldn't. So the music is a background task. It kind of just runs in the background, and then the foreground task is I popped open a calculator, or I popped out to the web, or I did something. Okay, so the difference between foreground and background, very, very common. Okay, and then of course you have the ones that are just most PCs are single user. They were never intended for two people would be sitting down operating the same computer at the same time. That's what personal computer is all about. And clearly, when you're talking about tablets and phones, it's a single user device. One person logged into the device, so to speak, and that's the only person who can actually be running anything at that time. Now, it's true that Windows operating systems do allow some hanky-panky, but that's not really relevant to this conversation. So, designed for single use. Now you have servers out there, and they are designed to have multiple users on at one time, all doing stuff. And so there's Again, so single task, very small, typically not used in anything you've seen. You know, then the little embedded devices and things like that. They are single user devices, single task devices. That's all they do. They don't do anything else. Then you have, you know, the multitasking kind where I can have foreground tasks and background tasks. And then you have the server kind where I can have many users with many foreground tasks and many background tasks. Okay, let's continue. On page 384, they talk about managing memory. One of the functions of an operating system is to kind of keep track of everything going on in memory. And the odd thing is that the memory on the machine could be exhausted relatively quickly. You could have, for example, 4 gigabytes of RAM, physical RAM, and yet when you add up all the things that the machine is using, you actually have exceeded that amount. Well, how in the world is that going to do? Is the machine going to crash? No, of course not. What it's going to do is it's going to say, let's pick one of these things that are going on that you're not currently operating, because a personal computer is probably only going to have one foreground task. Now, you can have as many background tasks as you like, but only one of them is going to be in the foreground. Okay? So let's say I'm really doing photo editing, but I left the browser up. Now, it knows I'm doing photo editing, and it knows that the browser is in the background. So what it's going to do, it's going to take this little chunk of memory here, and it's going to write it off to the hard drive. It's going to take the chunk, an image of memory, and swap it out to a disk. And then that'll shrink up, and it'll fit. And then I'm happy. And since I'm not currently running the browser right this very second, I'm actually doing photo editing, I never know that it had swapped out the memory. Now, as soon as I'm done with photo editing and I hit the browser one more time, it goes, well, wait a minute, hang on a second, let me go grab that from disk, and boom, pulls it back, and presto changeo, you're up and running again. Now, you can get into trouble if you have lots of tasks that well exceed the capabilities of your machine. And then things really start to slow down, because practically anything you do, like particularly if you're switching between tasks really rapidly, going across the icons here at the bottom and just hitting one, boom, 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 right down the row, machine's going, ah! Then you hit the next one, it goes, wait. Well, then, yeah, your machine can really slow down, because the amount of time it takes to swap this out is considerable. Well, considerable in computer terms. I mean, for us, it probably takes, well less than a second, but for a computer, that's an eternity. So there's a cool little diagram there talking about it. I'm going to pop open the task manager on my machine, just show you what's going on. So I only have 1 gigabyte of RAM on this machine, and I'm currently running 474 megabytes. So about 50%, well, 46% of the memory is currently being used. All I've got is a graphics thing going up here, and I've got a Internet Explorer, but I'm not actually running it. So that would be in the background, right? And it would be eligible for being pushed off to disk, but I'm not currently, I haven't hit the limit. So has it pushed it off the disk? Probably not. It probably wouldn't until I got somewhere around 90%. Then it would start pushing things off. So right now, everything that I'm doing fits in comfortably inside the amount of RAM that I have in my machine. Okay, that kind of make a little bit of sense? Okay. So in addition to kind of keeping track of memory and virtual memory means it's how many things I can have running and keep a balance of physical RAM and this pseudo RAM that's on a disk. Most machines, for example, about double. So most machines are configured so if I had 1 megabyte of real honest-to-God RAM, I probably had 2 megabytes of virtual RAM, about a 1 to 2 relationship there. That's typically how those things work. Okay. Well, actually, that's probably a good place to stop for the 15-minute mark. Pick us up again in just a few.